Okay, again here we have a cone, and in this case the cutting plane is something like this. They are just parallel to the, so this cutting, this is the generator and this is the cutting plane. So this is the cutting plane. In this case we observe this section is parabola. So basically what happened here, this is a cone, our cutting plane is this. Okay, this is our cutting plane, and if we see the angle, this angle is beta and this angle is alpha. So in this case this is the cutting plane, so we observe that this is the cutting plane. So in this case this is the cutting plane. So this is the cutting plane and this cutting plane is parallel to the generator. This is the generator. So this is cutting planes, this cutting plane is parallel to generator. That is, if alpha is equal to beta, we get a parabola. And this is the, basically this is the non-degenerate case, non-degenerate case. What happens if, so what happens if this cutting plane passes through the vertex of a cone? So let's see the degenerate. So we have to maintain alpha is equal to beta and pass it through vertex. So this is the cutting plane. Okay, so this is the cutting plane. This, now this is the cutting plane such that alpha is equal to beta and passes through vertex. And then what we observe here, the conic section. The conic section is just a line. The conic section is just a line. This is the conic section. This is the conic section for alpha is equal to beta and degenerate. Alpha into beta and passes through vertex. We get conic section as a straight line. Okay, so alpha is equal to beta and non-degenerate is a parabola and alpha is equal to beta degenerate case, that is a straight line. Okay, so this is a cone. You observe this is a cone. Okay, now we will have cutting plane. So just the plane is like this. So now we observe clearly that the plane is parallel to the generator. Cutting plane is parallel to the generator. So this is the cutting plane and this is the generator. It defined by alpha, this is defined by beta. With, so in this case clearly alpha is equal to beta, and the section, the conic section, we see that the conic section in this case is so we can see the conic section is the cutting plane and the conic section is a parabola. So you can see the conic section is just a parabola. So even though if I remove the, let's say, plane, we observe the, or if I remove, let's say, the cone also, we can see this is a parabola and the cutting plane. And let's move the position of a plane. If we move the position of a plane, so we are moving the position of a plane with respect to the cone. So now if we move the position of a plane with respect to cone, so we get a parabola. So in the upper if we cutting the cone, upper nap of a cone, we get a parabola on upside, and if cutting the plane is cutting to the lower nap of a cone, we are getting a downward parabola. Okay, so this is the, so we clearly observe that it is a parabola. So let's remove the plane. See, this is at different position, we are getting a, this is a parabola. As the plane moves, we are getting a parabola. Okay, so this was the non-degenerate case. Let's see what happens when the plane passes through the vertex of a cone. So now this is the case, we observe this is the case where the cutting plane passes through the vertex of a cone, and our cutting plane just passes through the vertex of a cone. Okay, so in this case, what is the section? So just I am removing the plane, and the you can observe, yeah. So you see this, the red one is the section. So let's remove the cone also, so you can clearly observe. Yeah, so this is the section, this is the section, yeah, this is the section. Okay, so this is just a straight line. So this is the cone lower nap, and this is the upper nap. So this is section is just a cone, and I will show you the position of a plane as well. So this is the plane. Okay, we observe that plane is just passes through the vertex of a cone, and in this case again this is maintained, because thing is, see, this is alpha and this is beta also. So alpha is equal to beta. So alpha is equal to beta, and the degenerate case we get a straight line. Here we are getting a straight line. Okay, in this case we are getting a straight line. So the degenerate case is a straight line. Okay, a single straight line. And now if I move the position, you can see that if I move the position, we get a parabola again. So yes, so this is, as it is moving towards the cone, its shape decreases and becomes a straight line, and it's again start moving away from the cone, the parabola will expand its size, and when it passes through the vertex of a cone, they becomes a straight line. Okay, so you observe that so suppose this is any plane, this plane moves, so the size increases as, and when it moves towards the vertex of a cone, its size more decreases, and then at the vertex it becomes line. Okay, so this is decreasing size towards the center, towards vertex of a cone. So as we move towards the vertex of a cone, its this size decreases, and the vertex it becomes a straight line. Yes, so this is the section. So and the plane moves away from the vertex, its size increases, so somewhere here it's, and then as we move towards the vertex, size it decreases, and that becomes a line, this line. Okay, we can see here that the plane is moving away from the vertex, then its shape increases, whereas move towards the vertex, its shape decrease. Shape decrease means they both the branches, the symmetric branches, converge to a straight line. Okay, so in case of a parabola, we observe that if alpha is equal to beta, they may represent a parabola or a straight line. Parabola is a non-degenerate case and straight line is a degenerate case.